right, so we are good to go. So before we continue our look at these key ingredients for inferential statistics, just a couple of brief announcements. Number one, we're going to take a very brief hiatus from the social media development and innovations and suggestions because of a conference that I'm prepping for this week. There just wasn't time enough to go to the next step. So just be aware, keep engaging with your communities, but we will come back to that on Monday. And then also, on that note, the conference that I'm prepping for is going to be happening on Friday and Saturday. It's the MSU Comics Forum. So it's a conference dedicated to people doing research on comics. So my lab will be presenting at 10:30 a.m. on Saturday. So if you're interested to see the kind of work that we do, it's all work done by undergrads here at IUSB. So if you're interested in seeing the kind of work that we do in our lab, I will be live streaming it live on my YouTube channel. So if you're up at 10:30 a.m. in the morning, feel free to sign in and take a look at some of the stuff that we're doing. The general theme of it is gender bias and comics. And we look at gender bias in clothing in comics. We look at gender bias in powers in comics. And then we also look at gender bias and violence in comics. And not to give too much away, this is my little teaser trailer. Some of our results are exactly what you would expect. And some of them are so counterintuitive that we're going to see how the community takes it. I'm kind of excited to start a ruckus. Anyways, all right, so what we're going to be doing today, we're going to continue on with our look at Chapter 4. Chapter 4 is a fundamental chapter. This is one of those chapters where we kind of turn a corner and start going from skills that we've been building in terms of descriptive statistics, and now we're going to take them and apply them to inferential statistics. So we're going to be dealing, for example, with z-scores today. And we're really not going to learn anything groundbreakingly new, except how to apply those z-scores in a new way so we can do new things. And those new things that we're going to, I'm going to keep bringing this example up because it's very important to remind ourselves why we're doing this in the first place. It's very important to remind ourselves, why is statistics a required course for your major? Why do we think that it is so important that we make you take it as part of your psychology education? And the reason has to be with how psychology functions. So once again, if you were dealing with a sample of autistic children, if you had 12 autistic children in a classroom, and all of your years of training led you to develop a new educational program for them, a new treatment, and you wanted to test it out, you wanted to see if it's actually better than the old way of teaching these children, you could implement that experiment. And at the end of the semester, you would test the children, and you could determine if these children scored higher than average using the old methods, or if they scored lower than average using the old methods, or if there was no difference. You could make that determination for these 12 students. Without stats, that's where it ends. You have helped these 12 students, you've invested a semester of work, and you've helped 12 people. And while that's really great, 12 people helped is 12 more than there were before. Inferential statistics is what allows you to take that effort and explode it into a huge impact so that you can generalize, and this is the important part, intelligently and without bias, because anybody can generalize, but the problem with our minds is we kind of see what we want to see sometimes. Statistics is a method to take that bias out of there so we can get to the truth and not what we hope is the truth. So statistics will tell us whether our treatment that we developed will work for the population. And if it will work for the population, that means that any autistic child anywhere in the world can use this program, and we can predict that they will benefit from it. So it opens up psychology to the world rather than just keeping it very small in that little sample area. And that's what we want to do. That's why this course is required. So what are we going to do today? We're going to have a very brief normal curve recap, just to remember the kind of ideas that we brought up last time. Then we're going to take a look at probability in the normal curve. That's where we're going to spend most of our time today. How do you get to probabilities using that normal curve. And we're going to look at how we're going to use z-scores for that, what the normal curve table is, how we read it, and how we answer questions using the table. And that's our plan for today. And incidentally, before we go any further, all your assignments up until exam 2 are now available on my lab. I have extended the deadline for pretest number 4, and I have made pretest number 4 completely bonus. So if you do it, it'll be added to your final grade as bonus points. If you decide not to do it, your grade will not be impacted at all. I know I was a little late on that, so this is my sort of thank you for your patience. All right, so the normal curve. So again, this is a mathematical theoretical distribution, and it occurs in nature very, very often. So the normal curve is that bell curve that you've probably seen when talking about, for example, IQ scores, when talking about the weights of people in a population, when talking about the heights of people in a population. We're talking about a lot of different factors about people in a population. And that's because this occurs when more than one random factor combines to give you a single score. And that happens in psychology so many times. There's very little that we do as human beings that is a product of one factor. There's very little that we do as human beings that's a product of one variable, one thing that happened in our life. It's usually a combination of many, many different factors. So whether you develop depression, there's genetics that play a part. There's exercise that plays a part. There's diet that plays a part. There's life stresses that plays a part. There's family support that plays a part. There's access to medical services that plays a part. There's a lot of things that play a part that determine that one single score. Are you going to develop depression? And that's why if you take a look at depression scores in a population, it's going to be on a normal curve. So once again, remember that a normal curve, this is a huge take-home point, is the product of multiple factors working together. So anytime you see a normal curve, even if it's just measuring intelligence, even if it's just measuring height, even if it's just measuring depression, just know that the fact that it's a normal curve means that tons of factors have contributed to make that single score. So that is, again, the big take-home factor. So normal curve and SAT scores, tons of factors go into an SAT score. Normal curve in heights, tons of factors go into the normal curve for heights. Normal curve for IQs, tons of factors go into that normal curve for IQs. All right, so we have this normal curve, and it occurs over and over and over again. So today we're going to see how we can use this normal curve to answer questions about probabilities. So for example, if we have this normal curve over here, and this is a very special normal curve, and we'll get to it, the details real soon, but this is a normal curve of z-scores. So it is a normal curve that has a mean of 0 and a standard deviation of 1. And we'll talk about why that's so important in just a moment. But if we wanted to know what percent of the population scored below a z-score of 1.25, what we're asking is, if this is the entire population, and there's your z-score of 1.25, we want to know what proportion of the curve is that blue area right there. So if you want to know what is the percent of the population that scored below 1.25, you're asking what's the proportion of that blue curve, and we're going to see how to do that today. Other questions that you might ask what scores bound the middle 50% of a population. So some factors, some characteristics of humans, you don't want too much and you don't want too little, right? So manic depressives, sometimes they're way too happy, sometimes they're way too sad. You don't want too much of something. So sometimes as psychologists, we want to figure out, well, how many people are sort of in the middle of the distribution? Not at one extreme, not at the other. And if you want to know what scores are going to give you that middle 50% of the distribution, well, you want the middle 50%, and we want to find out what those particular z-scores are. And in this case, it's 0.7 and minus 0.7, and we'll see how to get those scores as well. All right, and then this is going to be this is going to be one that's going to become Very important for you. It might already be important for you right now, depending upon where you are in your academic career. But if you're looking to go to grad school, oftentimes you'll see a grad school will say something like, we need GREs in the top 10% of the population. You know, our acceptance rate is only 10%. You'll see those kind of statistics. And you might ask yourself, well, what score do I need in order to be in the top 10%? And what you're asking is, I want to get into that blue area. That's 10% of the distribution. And we're going to see how to find out how much is 10% of the distribution. And that gives me a z-score of 1.25. And we're going to see, again, how to get that score. So that's what it's all going to be about today. How to find the proportions, how to find the scores, how to deal with this normal distribution. And the way that we're going to deal with it is we're going to use the tables that are in your textbook. So in your textbook, if you haven't opened it up, you can open it up to follow along. I got screenshots. But just so you know, in your statistics for behavioral sciences, in the appendix, in Appendix A, that is where you're going to find this normal curve table that we're going to be working with. And it is table A1. So that just gives you an indication of how important the normal curve is. It's the first table in the appendices. It's used that often. So that's where you can find this for when you're doing your homework. So let's take a look at how we're going to do this right now. So the first thing to point out is that this normal curve table, this is a z-score normal curve. So it's a very special table. It's a z-score table where all the scores here for the normal curve are with z-scores. And that's one of the reasons why z-scores are so important, because you might have a normal curve of depression scores, and you can convert them into z-scores and then use this table. You might have a normal curve of, grades on an exam, and you can't use the table for grades on an exam, but you can convert those grades into z-scores and then use it. So the fact that we can convert any distribution into z-scores means that this one table of normal distributed z-scores will function and be useful for just about any normal distribution that we might be interested in. All right, so how do we use this curve? So one of the first things we're going to do, let's take a look at how to read this table. So the first thing to notice is that there's 3 columns. So the table itself is kind of printed with 6 columns, but it's 1/2 on one side, 1/2 on the other side. And the table is multiple pages long, so you will have to scroll through to find the information that you want. But what we basically have is we have 3 columns here. And column number 1 is the z-score that you're interested in. So column number 1 is where you find the z-scores. Column number 2 here is the percentage from the mean of your distribution, from the center, to the z-score that's listed here, right? So this is the percentage from 0, which is the mean, to a z-score of 0.30. And that indicates that 11.7% is in that area. And very nicely, they draw you this little diagram. This is the area that is being represented by this column over here. And these diagrams are going to become very, very important. The last column over here, this is percentage in the tail. This is everything from the z-score and above, so that blue area right there. And that's the percentage that you see here listed in that column. So if we were to say something like, well, for a z-score of 0.3, how much of the distribution is above a z-score of 0.3? What you always want to do in these situations, especially when you first start, is you want to make sure that you draw some sort of mock-up of the area that you want, the area that you're interested in. So I did this on Excel. This is, completely proportional and accurate. But just something as simple as, all right, I got a normal curve here. That's 0, because it's a z-score unit normal curve. Now, let's call that 0.3. And I want everything above 0.3. All right, that's what I want. That's the area that I want. And what this does is it offloads 1, 2, 3 things from your working memory so that you can concentrate on getting the answer right. And what you're going to want to do is after you find that 0.3, you're going to want to say, which column does my picture look like? Does it look like column number 1 here? No, that doesn't match. Does it look like column number 2? Oh yeah, that's the one. And then you find the percent that's associated, and you end up with the right answer. In this case, 38.21% of the distribution is in that blue area. 38.21% of the distribution is above a z-score of 0.3. All right, let's say that we're interested in the other portion. Let's say that we're interested in the part of the curve that goes from the mean to a score of 0.3. In that case, once again, take a look at your picture, match it up to the column that you want. In this case, it matches this column. Find the percentage that is associated with that z-score, and we see that 11.79% of the distribution is in that little blue sliver that we have in our illustration. All right, and then the last one that we can occasionally ask for isn't on the table anywhere, and that would be the area below a z-score of 0.3. So notice that this blue area here is more than half of the distribution. So it doesn't match this picture here, and it doesn't match that picture there. So in this situation, what you need to do, and there's a number of different ways to solve this, but I'll give you the way that I oftentimes look at it. What you want to do is, once again, draw your distribution. Once again, shade in the area that you're interested in. And then what we need to realize is that this entire shaded area is made up of two parts. It's made up of this half over here, and it's made up of this mystery part over here. So that's two parts of this distribution. So what we can do is we can look up the mystery part, right? Because the mystery part is just a part from a score of 0, the mean, to your z-score, right? So if we don't worry about the half, we see that this is that second column. This we've done before. So we know that this little area is 11.79. And then to that, we add 50%. Because we know that the remaining half of the distribution is half of 100, it's 50%. So in this case, we take that extra little step and we figure out that the final percentage is 61.79%. 61.79% of the distribution is below a score of 0.3. All right, any questions so far? Okay, let's keep going. So another example, z-score of 1. If we're interested in what is the proportion of the curve that is above a z-score of 1, once again, draw your distribution. Once again, find your z-score of 1. Match your distribution to the column picture that you're looking for. In this case, it's this second one over here. Find the corresponding percentage, and we determine that there is 15.87% of the distribution in that blue area. From that z-score to the mean, so above the mean to the z-score, what is that blue area right there? Well, once again, draw your distribution. Once again, find your z-score of 1. Look for the column that it matches. In this case, it matches this column. Get the corresponding percentage. And we see that we have 34.13% in that blue area. And then finally, if we're looking for below a z-score of 1, first thing, realize there's no column for that. There's no column for when the area that you're interested in is greater than 50%. However, we split it up into two portions. The portion from the mean to your z-score, that's your mystery portion. Find that first. And then to that, we add half of the distribution, which is 50%. And we can see that 84.12% of the distribution is below a z-score of 1. So many people are below one standard deviation above the mean. One standard deviation above the mean, that z-score of 1, gives you over 84% of your population. All right, and then the last one that I just want to point out, because this is the only sort of like confusing aspect of it, is when you're looking up a z-score of 0. And a z-score of 0 is that very special case where you're looking at a z-score that's right in the middle. So if you're asking how much is below a z-score of 0, just know that that is technically the tail, even though it's splitting the z-score right in the middle. The tail is always the smaller piece of the distribution. So wherever you're cutting it, whatever is the smaller half is the tail. But in this case, they're equal. So in this case, they have 50% in the tail. And if they want how much is above the z-score, once again, for a z-score of 0, we got 50% in the tail. And very kind of tricky if they're asking what is the percentage from the mean to a z-score. Well, what's the percentage from 0 to 0? Not surprisingly, it's 0%. So that's just the one little tricky part just to keep an eye on. All right. So that's the basics of how to use that normal curve table. Any questions about that kind of procedure so far? All right. So what we're going to do now is we're going to take a look at 2 more slightly involved ways of using this table. Now that we kind of have the basics of how to use the table, we're going to amp it up a bit and look at how to apply this to a couple of real-world scenarios that come up over and over and over again. And these 2 scenarios are when you start with a raw score and you want to figure out a percentage, or you start with a percentage and you want to figure out a raw score. So those 2 types of questions come up a lot, and you'll see what I mean. So we'll start with starting with a raw score. And there are, I believe I have 5 steps for how to start with a raw score and get to a percentage. Step number 1, convert the raw score to a z-score. So in all of this, what we're doing right now, you need at some point to be handling a z-score, because the only way you can access the table is if you have a z-score. Sometimes you'll start with a z-score and go to the table. Sometimes you'll go to the table to figure out your z-score, but a z-score is in there somewhere. So in this case, we have your raw score, your regular score, and using the formula that we've learned, we transform it into a z-score. After that, we draw your normal curve. This is not in your textbook. I added this as another step. Draw your normal curve. It will save you. You will be mentally juggling enough things without trying to keep this in your mind. Takes 2 seconds, does not have to be to scale, but it'll save you from choosing that wrong column. So draw your normal curve, make a rough estimate. This is backup plan number 1. And then you look up the percentage associated with your z-score on the normal curve table. You check your answer against step 3, and then you have your answer. So your picture is backup plan number 2. That rough estimate is backup plan number 1. And let's take a look at how that might actually work. So let's say that you were, recall the days when you were taking SATs, right? So you're taking your SAT, and you find out that on one of the individual tests, you get a score of 333. Now, for the SATs, there is a mean of 500 and a standard deviation of 100. So those scores are standardized. So if you have a mean of 500 and a standard deviation of 100, so what percentile rank are you if you scored a 333? So how many people scored 333 or less? That's what a percentile rank is. So how do we answer this? What's the percentile rank for 333? Basically, how well did you do compared to the rest of the population? Well, the first thing we're going to do is we're going to take our raw score, that 333, and we have to convert it into a z-score. So we take that, and we remember our z-score formula. So raw score minus the mean, all in parentheses, and then that divided by the standard deviation. In this case, we're dealing with population data, but the formula is exactly the same. The moves are exactly the same, so it's not going to make a difference. So we plug that in, 333 minus 500, all divided by 100, and we get a z-score of minus 1.67. So step number 1, we have our z-score. Step number 2, we're going to draw the normal curve. So we draw our normal curve, and the area that we're interested in, that's minus 1.67 right there. And we want to know what is the percentage below, because you want to know how many people scored as high as you or less. So we shade in the area that we're interested in. So I've shaded it in blue here. That's the area we're interested in. And we want to have this handy drawn out somewhere so that we can refer to it when we go to our table. So backup plan, first backup plan. Second backup plan, we're going to make a rough estimate. And this is something that eventually you will stop doing as you gain more confidence with z-scores. But it's good to get it into practice at the beginning, just as a second backup plan. And also, some of your homework wants you to specifically do this. So we're going to go over it right now, just to kind of show you how that's all done. So we have our z-score of minus 1.67. We figured that out in step number 1. We drew our own distribution. We did that in step number 2. Step number 3, they want you to make a rough estimate. And what they mean by a rough estimate is they want you to use this table of approximate values and approximate areas to just kind of give yourself a range of percentages that you should be looking for. So that's what they want you to do. Just kind of get a range of where your answer might be so that if you get a final answer that's outside of that range, you know something has gone horribly, horribly wrong. So this is a graph of z-scores. And the way that you read this, is that this percentage here is for the area between the two z-scores. So from 0 to positive 1, from a z-score of 0 to 1, that's 34%, approximately 34% of the curve. From a z-score from 1 to 2, that's 14% of your curve. And from a z-score from 2 to infinity, all the way out, that's 2%. And I have no idea why they put that plus 3 there. That plus 3 is meaningless. It's confused so many students because they wonder, well, what's the percentage for that one? Ignore the plus 3. It's not used at all. Same with the other side. From 0 to minus 1, normal curve is symmetrical, 34%. From minus 1 to minus 2, 14% of the curve. And from minus 2 all the way down, 2% of the curve. Ignore that minus 3. So we're going to use these approximate areas as our second backup plan. So we figured out our z-score of minus 1.67. And we know that that's going to be somewhere in that range, right? So we don't have minus 1.67 here, but we got minus 1, we got minus 2. Minus 1.67 is right about there, give or take. So this is going to help us get a range of values. Because while we don't know how much is below 1.67, we do know how much is below minus 2, right? There's 2% of this distribution that is below minus 2. So we're going to have this 2% plus this little piece. So whatever number we end up with at the end, it better be more than 2%, right? That we know for sure. It's got to be bigger than 2%. So that's one end of the range. The other end of the range comes from the combination of these two areas, right? So we have all of 2%. We only have one little part of this 14%. So we know that we're going to be less than 14 plus 2, 16%. So this analysis lets us know that whatever percentage we end up with, it better be between 2 and 16%. So if we go to our table and the percentage says 28%, we go back to the drawing board because something went wrong. So this is just your backup plan, and that's how you kind of get that range. You look at your z-score, and you say, what's the minimum it has to be bigger than? And you take a look at your curves and you say, what's the maximum it has to be smaller than? And you'll usually end up with a range, something like that. So we know that our final score has to be between 2 and 16%. We got that backup plan. Make a rough estimate. Done. All right, so now we have everything in place. We're ready to look at the curve. Look at the table. So now we look up the percentage associated with the z-score on the normal curve table. So we have the z-score. We have that minus 1.67. Now we're looking for what's the percentage that is associated with minus 1.67. One thing that you'll notice is that there's no negative part to the table. So this is just a way that, I guess in ancient times when they used to print books on dead trees, this was just a way of saving space because it's symmetrical. The normal curve is symmetrical. So the right side is going to be the same as the left side. Positive side is the same as the negative side. So they say, let's just skip the negative side. They'll figure it out. So what we need to do is we need to remember that it's symmetrical. So instead of looking up minus 1.67, we're going to look up positive 1.67. And this is where your drawing is really going to come in handy. Because if you're wondering, what do I look at now? Because it was minus 0.67, but it was less than minus 1.67. So if I'm now mirror reversing it, and I got positive 1.67, is it now going to be less than more than? I mean, don't do that to yourself. We look up 1.67, we go back to our drawing, we want the part in the tail. It's very easy to just mirror flip a picture like this, but we want that part in the tail. We go back to our columns here. That does not look like what we just looked at. That does not look like our picture. That lets us know that that's the number that we want. 4.75 is the number that we want. So we got that number 4.75, and then we go to backup plan number 2. We check our answer against step number 3. 4.75 is between 2 and 16%, so that's all good. And that is our final answer. So in this case, if you got 333 on your SAT, you are in the 4.75th percentile, which means that 95% of the population did better than you, which means you should take your SATs probably another time. All right, any questions on that particular move? Or that particular type of question? Good? All right. Okay, so we saw how to start with a raw score. You got 333 on your SATs. What percentage are you in? What's your percentile rank? So that was starting with a raw score and getting to a percent. The other common thing that you can do is you start with a percentage and you go to a raw score. So sometimes you're given a percent to start with and you want to figure out what score do I need to get that particular percent. So if you're starting with a percentage, once again, we have our steps. Once again, I added this in, it's not in the textbook. Draw your normal curve. It is amazing to me sometimes when I just kind of check on work that students do, how many times they get all of the difficult, challenging stuff correct, and then they go to the table and they choose the wrong column. And if you choose the wrong column, it's not good. We're in psychology, we deal with people's lives. We're holding their lives in our hands. We got to make sure we don't fumble, at that 1 yard line. So draw your normal curve, take those extra few seconds, make your rough estimate. That's step number 2. So we got our 2 backup plans in place. You look up the z-score that's associated with the percentage that you were given. So now we're starting with a percentage. So we find that percentage on the z-score on the normal curve table. We then check that answer against our rough estimate to make sure that we have the right z-score that we're looking for. And then we convert that z-score to a raw score to finally answer the question. So an example of this would be, let's go back to those SATs. Let's say that you were trying to get into a very exclusive university that only accepted people in the top 1% of SAT scores. You might ask yourself, well, what score do I need? What's my goal? What should I be shooting for? What score do you need to be in the top 1%? So if it has a mean of 500 and a standard deviation of 1, what's that number when you submit and it shows you that number? What's the number you need to see to make sure you're in the top 1%? All right, so the first thing we're going to do is we're going to draw our normal curve. Once again, it doesn't have to be proportional, it doesn't have to be accurate. You just need to identify, are you looking for a tail? Are you looking for the body? Are you looking for a piece? Whatever it is, in this case, we want the top 1%. So that's 1% or above. That's that little blue area right there. We got 99% below our intended area. But now we've offloaded this from our working memory. We have it. It's on paper. We can refer to it. We don't have to think about it anymore. Step number 2, we make our rough estimate. So once again, we go back to that figure that is in your textbook with those rough areas, those approximate areas. So make sure that you are accessing that figure when you're doing your homework, because again, it will ask you to use that figure to make approximate calculations. So we have our 1% above. So this time we don't have a z-score, but we have a percentage. So once again, we have to find on our kind of approximate graph here, whereabouts is 1% in the tail. So this is 2% in a tail, right? This is 2% right here. So it can't be this whole thing. It's got to be less than that whole thing. So maybe it's somewhere there. Maybe that area above here is 1% of the curve. So we identify that 1% above. And then what we do is, once again, ignore the 3. We don't have an upper limit this time, but we know for a fact that we want part of this. So it's got to be a z-score that's bigger than 2. And that's the estimate that we have this time. So we don't know exactly what that z-score is. It could be 2.1, it could be 4.1, it could be 182.1. We don't know. But we definitely know that it's bigger than 2. Because 2 gives you 2% of the tail. A bigger number is going to give you less than that. So we don't know what it is, but we do know our z-score that we find on that table better be bigger than 2. So we have our rough estimate. Next thing we do, we look up the z-score associated with the percentage that we're interested in. So we go to our table here, and once again, you want to make sure that you look at your picture and you find the percentage that is in the column that looks like your picture. So when we go to our z table here, we're going to be looking at this column and this column only. Remember, we're given a percentage. These are percents. So be very careful not to make the mistake of looking in the z-score column either. We're looking for the percentage in the tail, so we need to find that 1% in the tail. Sometimes this table is going to be very, very friendly, and you're going to see the exact percentage you're looking for. Sometimes the table is not going to be so friendly, and you're going to have to do the best job that we can. So in this case, there is no 1% listed here. But we have 1.02%, and we got 0.99%. And we just have to determine that 0.99, that's the closest we can get to 1%, right? It's only 0.01 away. The other one is 0.02 away. So that's the closest that we can get. So 0.99 is our percentage in the tail, right? So that's the 1%. What we do then, we've checked with our picture. We know we want a z-score that's above 2. So we found our percentage. We scroll across. We get our z-score now. And we double check. So we have a z-score of 2.33. We go back to our rough estimate. And a z-score of 2.33 is matching our rough estimate. That actually is greater than 2. So again, we have our 2 backup plans. We know we got the correct z-score. Down to the final step, we found the z-score. Now it's time to convert it into a raw score. So once again, we use our previous formulas, right? Everything is going to be carried forward. So we have raw score equals the mean plus your standard deviation times your z-score. We just found our z-score of 2.33. The other information is given to you in the question. So 500 is the mean plus 100 times 2.33. And that gives us a final score, a raw score of 733. And what that tells you is that if you want to make it in to that top 1%, you're going to need to achieve an SAT score of 733. All right. Any questions on that? All good? So everybody knows the 2 ways, confident that you can at least follow the steps? Okay. So this is, before we end today's class and turn it over to practice time, this is one of those things that I'll just keep mentioning a couple of times, just so that you know sort of how to plan your upcoming exam. So it's not going to be a surprise. On the upcoming exam, you're going to have questions where you start with a raw score, and I'm going to ask you for percentages. You're going to have questions where you start with a percentage, and I'm going to ask you to try to find a raw score. These are the steps that you need to do. No point when I was learning stats did I ever try to memorize these steps. These steps you will learn and you will memorize just by doing it over and over and over again. So until that day comes, again, feel free, print these out, have them bookmarked. You know, download the student lecture slides and erase everything and save it as a sort of like Cliff Notes version, or Cliff Notes is what you guys have in the United States. Yeah, we got Coles Notes in Canada, so I don't know if you guys have ever heard of that. It's basically the same thing, except they put A every once in a while and they're summarizing things. But anyways, yeah, I mean, just have, maybe build a PowerPoint file that has nothing but kind of like the highlighted steps, because when you get to the exam, feel free to pull this slide out and be like, all right, step 1, what do I do? Draw a normal curve, here I go. Step 2, make a rough estimate. Because, you never have to try to commit this to memory. You will memorize this at some point, but you'll memorize it through doing rather than trying to memorize it. All right, so on that note, this is old. I need to, no, that is correct. Okay, so on that note, you are now ready to do homework assignment number 6, chapter 4, part 1. So that one is, like I said, available. That's the kind of like beginning one of this, this part 1, part 2. So that's going to be due Wednesday by midnight before we meet again. There is a deadline on the pretest number 4. So make sure that you check that. The deadline has been extended for that. I believe it's something like the 26th, but double check. But again, just so that you know, I don't know how to do it, set it up so that it works this way in my lab. But pretest number 4 will be complete bonus. So feel free to run it through a few times. Feel free to do it after we've covered, a little bit of chapter 4. But yeah, that's going to be 100% bonus points. But for the other pretest points, don't forget about earning the mastery points from the MyStat Lab study plan. But other than that, I am done what I wanted to cover for today. So you now have homework assignments to do. So if you want to get started on some homework here, if you run into trouble, feel free to come put your hand up and ask me to come over. If you want to call it an early day, feel free as well. But we are done covering what I wanted to cover today.